Hi, I'm Marcellus English, and this is Lab 3 Circuits. Let's go. So the goals of this lab are to predict the behavior of circuits that have resistors both in parallel and series, and then use multimeters to measure the real values of conventional current and the potential differences in these circuits, and examine the behavior of ohmic resistors and capacitors. And our findings are that the current in the resistors was 0.02 amperes, and that more resistance in an RC current equals more time for the capacitors to charge. Let's go. So the concepts that were relevant were the node rule, which is current in equals current out. I mean, I use a dash, but life goes on. V equals IR, P equals IB, and the loop rule, which says that change in electric potential for a closed loop equals 0. And lastly, the idea of capacitance. So the procedure, first you have to construct a circuit with two 1.5 volt batteries, 2 ammeters, and 2 resistors, plus a 47 ohm and 100 ohm resistor, and then record whatever happened. So here's a diagram of that. And then the current in I2 was 0.02 amps, the current and I1 was 0.02 amps as well, and the reverse current was negative 0.02 amps. Makes a lot of sense. Let's go. Next, we had to convert one of the ammeters to a voltmeter and record what the two multimeters read. Here's a diagram of that, and then we found that current I2 was 0 amps. Don't know why I put V1, but because of the theoretically infinite resistance in the voltmeter, there is no current measured by the ammeter, aka 0.00 amperes. Next, we had to disconnect the voltmeter and measure the voltage across the different elements again. So in the 47 ohm resistor, there was 0.96 volts, and the 100 ohm resistor, 2.01 volts, and the ammeter, 0.10 volts, which told us that the wires in the rest of the circuit had a voltage drop of 0.05 volts. Here's a graph of the voltage drop. Super interesting, I know. Let's next. Fourth, we connected one of the ammeters in parallel with the 100 ohm resistor and measured the current at both ammeters. So the current of the ammeter in parallel with the 100 ohm resistor was 0.057 amperes. The current of the normal ammeter was 0.05 amperes. And we said normal because we had to use like 4 ammeters and like ask our TAs, and like this lab was crazy, but like I love physics too. Like let's go, let's get this endless test. So yeah, last we had to construct an RC circuit with two 1.5 volt batteries, a 1F capacitor, and 2 bulbs of different resistance, and then observe the charging of the capacitor and the discharging of the capacitor, aka like the bulbs lighting up. So here's my boy Matthew going crazy on that. I mean,
Now we'll do the
come on,
discharge.
come on, bing, let's go. All right, next.
That's discharge.
Jeez, all right, hold on, that was crazy.
That's
2.5
discharge.
minutes. Y'all see that? One more.
Idea, by the way.
Yeah, that bit. Excuse me, sorry. Excuse the cursor.
That's
That thing
discharge.
lit. All right. So calculations and data, resistance for each component, 47 ohm, here's that data, 100 ohm, here's that data. Wow, I mean, pause the video if you really love tables. All right, last, let's go. So discussion, what if we charge a capacitor with no resistor in the circuit? So theoretically, the capacitor would charge in an instant, snap of the finger, because the potential difference from the battery would immediately charge the capacitor. But in this guy said teal life. In real life, let me take a breath. However, in real life, the wires will give a small amount of resistance that slows down the charging of the capacitor, plus the internal resistance of the battery, which means like the chemical makeup, because the chemical's got to go bing, bang, boom before anything happens in the battery. And yeah, so thanks. Happy Sunday. Good luck on the test. Let's get this A. Let's get this pape. Love you, twin.